As we said in the previous video, signal levels are measured in decibels, or dBs, and decibels measure different kinds of energy in different applications. Different levels of gear operate at different signal strengths. In professional audio, a 0 on the VU meters indicates an amplitude of +4 dBu. In consumer equipment, that same 0 means a signal level of -10 dBV. The important thing is to match the levels of the gear you're using. Often, a mixer or preamp will have a switch or a control that covers the range between -10 dBV and +4 dBu, so you can keep the signals matched if you use both types of gear. You'll also see decibels used to measure acoustic volume or sound pressure levels, where 0 dB SPL equals the absence of sound, no sound at all. Certain shock waves, like a sonic boom, have been measured at greater than 194 dB. Sounds as loud as 120 dB can result in permanent hearing loss, so it's good to be careful with very loud music. Human beings don't hear different frequencies the same way. In other words, our ears don't have a flat frequency response. We don't hear low-end bass and high-frequency treble sounds as well as we perceive sounds in the mid-range near 2000 Hz. So sound pressure levels are given different weights, A, B, and C, according to volume and frequency. There are some other terms you should know about the analog gear you work with. The signal-to-noise ratio is a measure of the difference between the level of a signal and the noise the gear produces when it processes that signal. The higher the SNR, the better. Digital gear keeps SNRs much higher than analog gear of the past. The dynamic range is closely related to SNR. Dynamic range measures the ratio between the strongest undistorted signal on a channel and the minimum discernible signal, which for most purposes is the noise level. Total harmonic distortion, or THD, measures false tones in a signal. Musical material contains distinct tones, and some kinds of distortion have tones that double or triple the frequencies of the musical tones. That distortion is called harmonic distortion. For high fidelity, THD is usually expected to be less than 1%. Impedance is a measure of resistance to electrical current. High impedance circuits are low current, high voltage, while low impedance circuits are high current, low voltage. With microphones and electric instruments, low impedance connections to inputs result in higher quality, more consistent signal. That's why engineers use what's called a direct box to change a high impedance or high Z signal to a low Z signal. With outputs to speakers, the impedance of the power amps must match the impedance of the speakers for the most efficient reproduction of the sound. The primary component of any digital audio system is the converter. When you're recording, the analog to digital converter turns your audio signal into data that the computer can then process. When you're listening to playback, the digital to analog converter turns the data back into audio signals that drive your monitor speakers. Converters come in different levels of quality depending on the audio interface hardware you choose. You can go with the most basic entry-level converters, such as the ones built right into your computer, all the way up to high-end systems used by professional recording studios like this one. Let's take a look at the functions and different types of converters available. An analog to digital converter, or ADC, converts a signal with continuous voltage to digital numbers that represent the signal's changing amplitude. The AD doesn't measure the voltage continuously. Instead, it measures or samples the signal at precise intervals. Converters have the characteristics we've discussed, such as bandwidth, signal-to-noise ratio, and dynamic range. Their quality depends on several factors, including resolution, linearity, jitter, and other characteristics. For recording, we mainly concern ourselves with the converter's sample rate and bit depth. In the early days of digital audio, the recording industry settled on a resolution of 16 bits, the word length of a sample, and a sampling rate of 44.1 kilohertz, the frequency in samples per second. After a while, however, it became clear that higher bit depth and higher sampling rates could result in more accurate and better sounding audio. Today, almost all audio interfaces have resolutions of 24 bits with sampling rates as high as 192 kilohertz. Audio professionals debate whether higher bit depths and sample rates actually result in better sound. All of the recorded music from the first track of a recording project to the final mix is encoded with a certain format. CDs use a digital audio format called pulse code modulation, or PCM. These data streams go onto compact discs and digital music files. Any DAW that you're likely to use will produce this type of format. The direct stream digital, or DSD format, though not widely adopted in the US, is used for high-resolution super audio CDs, or SACDs, broadcast applications, and direct downloads. High-resolution audio can be recorded in these formats and then downsampled to 16-bit 44.1K resolutions for CDs. A lot of the things we talked about today may seem overly scientific and not so relevant to the things you're looking for from these videos. Why do I need to know about this and why do I need to know about that? And believe me, a lot of engineers and a lot of great producers don't know all the scientific terms and all the arcane nuts and bolts of the things that go into the electronic side of recording. But when you're buying a piece of gear, a microphone, for example, or a converter, or even a guitar with a certain kind of pickup, if you have a little bit of knowledge about impedance, for example, or sampling rate and response curves, you'll actually know what those specs at the end of the blurb are talking about, and you can make a more informed decision instead of relying on what the guy at the music store is trying to sell you.